Today, we're going to talk about tricks and mathematics and the damage it can cause.
So, David, what you're saying is that sometimes there are mathematical things that we tell the students in an effort to help them, and it's like a shortcut that might make the problem easier to do in the moment, but then in the long run may cause some misconceptions to occur in students, so that when they're trying to apply that to upper level mathematics, it causes them to miss the problem or not understand what's going on.
Why would we even consider tricks in the first place?
Well, I know for me, I'm just as guilty of teaching the student a trick as anyone, because I think sometimes as a teacher, I'm concerned about giving them something to do when they don't know what to do in an effort to be successful on an assessment, or maybe I feel like I'm running out of time. And so I go really against my belief as a math teacher that the concept can be developed in a way that kids understand it. I go against that nature and teach them something that they can do in a pinch or a quick, and that's where I get caught up in it. And I really feel like many teachers fall into that category. I'm trying to make it easier for the student to understand. So I'll teach them this little shortcut. But I think that when we do that, that's really not the case. We think the shortcut helps them understand, but it doesn't really give them the understanding that they need for mathematics they may learn later on in their school career.
It kind of reminds me of when parents tell their children to do something and the kids, their children ask why, and the parent just says, because I said so, or because that's what I said, or just because. And so sometimes I think of shortcuts in kind of that same comparison of, I'm just going to tell you this to speed along the process and just do it because I know it works, and I just do it and just take care of it. And I remember when I was teaching third grade one year, and at this particular time they were doing probability. This was before the standards changed, and I remember going through and trying to help them, work through that concept. And maybe it wasn't third grade, sorry, it was fourth grade. But I had an instructional coach come in, and this was like one of my students was really, really struggling to grasp. And so they were working through it. And the instructional coach whispered and said, "Hey, just do this." And she came over and she thought she was doing a good thing. And I was like, no, like, I don't want that for them just yet. Like, I want them to discover that on their own. And I just remember that sometimes when kids get to that level of frustration, we want to rescue. That's what we do. We want to rescue, we want to help them, we want to alleviate. And sometimes when we see that level on students, we just want to give them the quick fix so that we can move past.
For me, the problem with tricks is essentially they don't remember all the rule, whether it be keep change, or negative and a negative makes a positive. They don't remember the part in the middle, which was, when do I use this shortcut that actually makes it faster to do it than the long computational way? And it's that misapplication that causes so many problems downstream, eh, not just in your year or class or unit, but the next year, 2 years down the road. As an algebra teacher, I constantly had to change kids' minds of, don't just flip the subtrahend and minuend because the first number is smaller than the second. I'm in the middle of algebra 1 having to have that literal conversation, and that needs to be something that needed to have been taught, but somebody along the way just said, I'll just flip them, it works. And it never got corrected.
You
So
bring
it sounds like, David, that is the math shortcut that drives you crazy.
Oh no,
Um,
there's more. There's much
there's
more.
more.
There's
Um,
much more.
much more. Well, it sounds like that one right there kind of has you on, like, maybe you just recently saw that and you're like, I just want to, help teachers with that. Faith, what would you say is a math shortcut that really drives you crazy?
Well, probably the top one is the butterfly method, because it's a shortcut that teachers tell students that could be easily, with just a little tweak, be easily changed to support the conceptual understanding of the fractions and how to compare them, but they miss it by doing the shortcut. And it just takes like one little thing to change it, and it would be much better. But that's mine, the butterfly method. Kill the butterflies.
All of those tricks have a downstream problem. And there was a great book by, forgive me for not remembering her name right now,
Tina Cardone.
called Nix the Tricks. Faith, you want to tell us about that book real quick?
Actually, yeah, I do. That it's a great book Tina has been working on, and it has updates. So she started this little project, this book, online for free. Teachers can access it even now. Just have to type in Nix the Tricks, and people have added to it. And so what I like about it is it talks about the different tricks that are out there, but it gives like what to do instead. So here's the trick, why it's not helpful, what happens later on down the line. Here is a better way of doing the same thing that is more conceptual, leads to more understanding. And so I would really recommend you looking that up on Nix the Tricks on the internet and downloading it for free, because I think you find a lot of good information in there.
Make sure to include a link to that on the description to this video later. We asked Region 11 in the Twitterverse, what was your least favorite trick? And we picked on 4, keep, change, the butterfly method, just add a 0, and alligator eats the bigger number. The results of the polls that we ran on both Twitter and Facebook came back with the top 2. Michelle, what are the top 2?
Well, you just heard Faith talk a little bit about the butterfly method. So that one definitely came in as one of the top ones. And the other one was alligator eats the bigger number. And what's interesting about these 2 data is that we did not just ask educators. We opened this up to anybody that follows our social media account. And we got feedback back from parents, from students, from teachers, from coordinators. So we had a wide range of people commenting on these 2. And we ran this poll actually a second time on Twitter just to see if we would get different results. And we actually came back with the same results, with butterfly method and alligator eats the bigger number came in, both of those again as the top 2.
So let's go ahead and talk a little bit about exactly what they are, what are the common mistakes that can happen because of it, and what really is the conceptual damage that we're trying to avoid. So we'll go ahead and start. Faith, you drew the short straw and you picked a butterfly method. So why don't you let us know, what is the butterfly method?
Hashtag Operation Kill the Butterfly Method.
Thank you, Michelle. I like that. Okay, I always support that hashtag. So in the butterfly method, we are trying to compare 2 fractions. And the shortcut here is that you multiply diagonally the denominator to the numerator. So if I have 2 fractions, the very first fraction, I multiply the denominator of the first fraction by the numerator of the second fraction, and I write that down. And then I reverse it and take the denominator from the second fraction and multiply it by the numerator of the first fraction and write that number down. And then now I have 2 numbers that I can just compare these 2 numbers, and whichever one is bigger, that means the fraction closest to that numerator that had that number is the larger number. And so it's very handy, works every time. So, and I see it happen way too early, even if it was a strategy that you wanted to utilize. I see it happening way too early in the grade levels, in 3rd grade, when we're supposed to be developing understanding. We're going straight to this method instead of using the time and the standards, what our standards say, to develop the contextual understanding. We just teach them that really shortcut. And David, you want to say a little bit about what happens later on with that?
The butterfly method has one devastating effect. Whenever children see 2 fractions side by side, they feel they must use the butterfly method. It doesn't matter what operators in between them. It could be add, subtract, multiply, divide, equal, square root, apple. I don't know. What anytime they see two fractions side by side, their instinct becomes the butterfly method. In geometry, and later on when we were trying to do proportional reasoning, we need that skill of cross multiply, but they're looking at it for the wrong way. And the sad part is when we go later, I loved asking the question of what's a number that makes this work, and they're clueless. It is crazy what happens because of that devastatingly. If you see two fractions together, use the butterfly, and it comes back and just haunts us all day long.
So David, I'm actually going to add to that because you mentioned what I think is another trick. I think cross multiplying is another trick that gets overused and and for the same reason as the butterfly method is that we teach kids kind of to do it without this understanding of what a proportion is and how it's working and the other things that we could do to help solve that kind of problem and what we're really looking for. So I think that to me, cross multiply and divide is an extension of the butterfly method. But as I said earlier, this trick can be easily adjusted to provide some conceptual understanding. For example, if I'm trying to compare two fractions, one of the strategies for comparing two fractions is to find two fractions that have a common denominator. And so I could use that same strategy where I'm multiplying the numerator and the denominator of one fraction by the other denominator in order to create two fractions that have the same denominator. So the shortcut is really what we find out is when I multiply for that denominator, it's the same in both. So it's like, I don't really have to do that step. But for kids, I think it's important that they see that, oh, so what I just did is create two fractions that have the same denominator. And now it makes sense of why I can compare those two numbers to say that one fraction is larger than another fraction.
And likewise, in middle school, there are 3 ways to solve a proportion, and cross multiply is one methodology. Using the unit rate or the scale rates, you can actually solve it different ways, which actually builds onto the relationships when we talk about proportions in geometry, because now it blows my kids' minds that you're looking at the reason why a proportional problem is solved by cross product is because the product of the means and the product of the extremes are supposed to be equal for it to work. Means and extremes makes no sense to kids if they just go butterfly. So lots of conceptual damage can occur.
But I've had teachers tell me that they don't understand why it works themselves. So they're teaching a shortcut that they really themselves have no understanding of what it is that's making that trick work. Just know it does. And I think that's detrimental too. Michelle, would you want to add anything to that?
Honestly, no, I think that between both of y'all, like looking at it from the upper elementary and then the secondary perspective, I think you guys hit pretty much the important parts on that. I would just say that I think fractions in general are underdeveloped and oversimplified. And I think because of that, that leads to this idea that the butterfly method is simple and that students understand it, because if they're good at their multiplication facts, then they've got it. And if they understand comparison and larger and greater than, and I think that the depth of where we're trying to get in general with fractions is really kind of the root of that, and why the butterfly method, I think, is a go-to for teachers. It's hard to grapple with things that that you don't understand, and then to teach that to students, that's a hard place to be in. And so I think sometimes we do look for a simpler way out.
You want to start us on the next one, the alligator method, or the second most hated trick is the alligator eats the bigger number?
So that's the wonderful passion about the butterfly method, hence the hashtag Operation Kill the Butterfly Method, one instructional activity at a time. Okay, so the other one that was a top one was the alligator eats the bigger number. And where we see this come out is in our primary grades is where it begins. And then it just continues. And so basically what this is it's kind of like a cutesy way of comparing numbers. When we talk about trying to determine what numbers are larger or what numbers are smaller or greater than or less than, we attach the symbol to it, which is just basically a sideways V. I'm sure there's a more mathematical term than that. But what we see is that there's all these cute posters and all these cute names for things, and we tell students that if the bigger part is facing to the bigger number, that the alligator eats the bigger number, and so that's the direction that you face it. And then they have them draw these really cute little eyes and little bumps for the alligator, and it just becomes this really cutesy thing. And while it seems to really be impactful on the primary grades, what we find out is in the secondary level, students still struggle with comparing numbers, because now they're comparing numbers with decimals and percentages and fractions, and the numbers are no longer whole numbers, or no longer just whole numbers. And the alligator eating the bigger number begins to kind of fall apart, in my opinion, because one, middle schoolers are not going to draw the alligator cutesy stuff. But two, they never really understood why numbers were greater than other numbers. They really understood when you look at a number line, where numbers fell on a number line and why that number was greater than this number. So as they progress past fifth grade and move into sixth grade and they begin looking at positive and negative numbers, now we've got two whole numbers, but one has a negative sign, and now how am I supposed to compare? Well, they're the same number, and I don't know which direction the alligator goes because they didn't fully understand what the numbers, what they represented, and the distance from each other, and why one was larger or greater or smaller or less. And so I think that that's why this drives some people crazy, is because, yeah, it doesn't have a lasting impact on the mathematical understanding as they progress forward.
Well said, Michelle. One of the things that I ran into with my students with this greater than and less than symbols is that just like the equal sign, sometimes the kids get in their mind that the equal sign doesn't really mean that the two sides are equal to them. Sometimes it means the answer is coming. And so the same thing kind of happens with the inequality symbols, is that when I see an inequality symbol, sometimes I just associate it with the number, just one of the numbers on this side and one of the numbers on that side. When I'm really talking about the whole side of the equation. So what if I have x plus 7 is greater than 15 plus x? All right, I'm thinking about values to make that true, but I'm not talking about just the numbers that are beside the sign. And so that to me is like, that's thinking about inequalities and graphing inequalities and all of the things that are associated with that. If that beginning instruction doesn't support those higher level ideas, then I have to undo a lot of misconceptions right there on inequalities. What would you say, David?
For me, that damage of alligator eats the bigger number never really addresses like position on a number line, like Michelle said. The notion that when we get to secondary, we're now solving inequalities with one variable. So like, it's not that x is greater than 5. Is x is every number to the right of 5 on the number line. And you can pick any one of them and be correct. Any one of these numbers over here on the right-hand side is going to be bigger than 5 and makes it work. Then we have to throw in greater than or equal to or less than or equal to. So it's that position on a number line that is just avoided. And that's just so what we rely on so much later. And I was just thinking the problem too is, why is it when we divide by a negative or multiply by a negative number, the sign has to change? Why is it?
That is a great.
What's really going on there that the alligator has nothing to address? So it's a very, very short-term, quick trick to get through problem 37, but it doesn't help me next year, year after, in high school, in middle school, on. It's just to get me through this assignment. And that's the most devastating part of that thing. They learned one thing that they should have learned a lot more just by observing it. So I'm just looking at all the damage that we have in Algebra 1 with domain and range, because we have to write it in an inequality and the kids don't get it. They just know that the arrows point one way. and they don't really understand what's happening there on a number line. So, and God bless, forgive me with graphing linear two variable inequalities, where now you have to determine not only which way does it shade left or right, but up or down. And it's just, all of this just comes through because, and I hate to say it, it was a teacher trying to get us through problem 37.
Well, and I think that as both of you were talking, it's really being able to describe what's happening. If what I find is that kids can read it from left to right. So let's say it's 56 is greater than 19. But if I ask you to read it the opposite direction, 19 is less than 56, they don't grasp that I can read that in two different ways. So they just see it as one solution and one solution only. And so I love that you brought in this idea that it's really all the numbers beyond as they get older and they start looking for greater than or less than, and it's more than just one number. Because I think that in the elementary side, we're looking for one solution and this is it and that's it. And I think if they could start working, because I was thinking, how can we help this one? And I'm sure the book Next to Tricks has some ideas too. But I think one of the ways that teachers that we could really help support this to help as they move into secondary mathematics, because we can hear that there's a big implication for this, is really begin to have them describe and talk and use models and to begin to really discuss and looking at it from multiple perspectives. And I think if we can, on the elementary side, can focus more on what's happening and why it's happening, communicate it, that maybe we'd be able to support them better as they move into higher level mathematics in secondary, whether it's middle school or high school.
Thank you, Michelle, for saying that. I think that is so true because to me, it's that connection between the mathematics and the comprehension of what, like reading that number sentence, what is that saying? That so I have to get my reading skills, my comprehension skills, and my schema together to interpret what is it that this number sentence is truly saying. And I want to build on something that David said, because we see that sometimes when we rely on these tricks in early elementary school, like at the Alligator, what happens is that when that idea shows up again, we have to then start relying on new tricks. Because so what he mentioned was that when when I'm dividing or multiplying by negative number across the inequality, we have to flip that inequality. And that's a trick that we teach them. We just say, you just do it. But if we really understood the meaning of early, building on it from early elementary up into middle school, we wouldn't have to rely on telling them that trick. But they would understand, they would be able to read and comprehend that number sentence in a way that makes sense.
And I want to say one thing before we get done with the podcast for sure, is we're not bashing elementary teachers. You guys do some wonderful work. We all do shortcuts, tricks, get arounds at every level that have damage to later on. Don't talk to college professors about algebra teachers. Just don't do it, because they're going to wear you out about what we didn't teach. So it's all of us. We need to understand that. Let them struggle with the concept first, and then come back after they've kind of got it a little bit, and then show an efficient way to solve the problem. Then a trick is not a trick, it's an efficiency. Then you understand all the basics. Now here's a way to do it so we can go a little faster so you can get to other stuff. And they now have the learning, and then they have it. But if you just taught the trick, for instance, if you just taught FOIL and never really taught them what is going on, why does this work this way? Here's a model to kind of help. I mean, it's just another algorithm. And then that's where we have problems later on.
Well, because our brain has to build connections. And so when we're teaching in isolated tricks or isolated anything really, it doesn't have anything, the brain doesn't have any synapses to connect it to other types of thinking and understanding. So when we build in language and models and all of those conceptual pieces, it creates a bigger pathway to that idea in the brain. And it's not just an isolated piece of information that I have to find. Oh, I remember this trick was something about, I'm supposed to flip one of these over. I can't remember which one. I'm really not sure why. It's just that, so, but if they have built that understanding through all these different modalities for thinking, listening, speaking, writing, modeling, then we're building such a stronger, more dense understanding of that idea and that concept.
When I think when kids can arrive at that themselves, then they've learned it. So I think it's not that we don't want to talk about them. It's just that we don't want to lead with them. We don't want that to be the primary instruction. We want the students to discover and explore and come to that kind of on their own, and then be able to explain why that works for them. Because that's what we want for our students, is to be able to take what we're learning and own it and create ownership over it. And that's where they have to go through all, like Faith was saying, all these different ways of doing it. And then if they arrive at this shortcut on their own, you can be surprised, like, oh, wow, I didn't know that. Tell me more about that. And then it's like they discovered it on their own. And talk about empowering learners. Then they brought it to you and you just affirmed them instead of you telling them and then they affirming you.
Well, it was a really great discussion today. I enjoyed talking about it. And Michelle, what's that hashtag again?
Hashtag Operation Kill Butterfly Method.
That's a long one, but I'm a supporter.
I will encourage you
We're gonna
to
get in trouble for saying the word kill. I'm just throwing that one out there. Can we say seriously wound or maim?
how about we say Operation Destroy?
How about eliminate? I don't know.
Eliminate.
Butterfly method.
If you have a better word, drop it underneath this podcast and maybe we will update our hashtag with a more appropriate word. Hey, so I would totally recommend looking into Nix the Tricks, especially just to take a look at. Maybe there's one in there that you didn't realize was a trick. And maybe what is going to be powerful out of it is, like Faith was saying, it not only tells you what it is, but it gives you an opportunity to see of another way of approaching it. And so I would encourage you to take a look at it, see if there's something in there, and stretch your brain just a little bit, and let us know, if there's one that we didn't mention that just drives you crazy, or if you realize, hey, I've been doing that and now I'm trying this and this is my new impact. We would love to hear celebrations of anything that you do to nix the tricks or to eliminate the butterfly
method.
Trying to think of another cutesy thing, but I got nothing.
Squash the butterfly.
Oh, there we go. We say squat. Well, that's kind of mean.
You went from kill to squash. Oh my goodness.
Well, squash is
Squash won't
different.
get
Like
me in
kill is just like
trouble.
bam. Squash
Well,
is like, oh.
You squashed it. If you kill it, you squished it.
No, I can kill it by spraying with some water.
How about free the butterfly?
Stop.
Hashtag free the butterfly. So the butterfly can be a butterfly and not some math method.
Oh, okay.
Okay.
So I'll say that you'll have to wave that in. So we are doing Operation Free the Butterfly.
I like it.
Operation Free the Butterfly.
I need to point out that the former wrestling coach and football coach was the one that used the non-violent language. Just throwing that out there.
That's awesome.
Unfortunately, that's all we have time for today. Follow us on Twitter at R11MathNow, where our motto is
Professional learning.
Anytime.
anywhere.